Hello everyone. In this video, I am going to discuss again the questions on complex numbers. In the previous video, we discussed some very good questions on the same topic. So if you have not seen that video, please go through that video. Okay. So let's start with the first question here. So the first question is, for a complex number z and omega, prove that z square omega minus omega modulus square z is equal to z minus omega if and only if these are the conditions. Okay. So this question can be made objective question also. Okay, ये subjective question था, but it can be very easily made objective question. So the idea here is this condition implies z is equal to omega or z omega bar equal to 1. ये आपको prove करना है. Okay. So see, first thing you can observe here clearly that if I just take some common terms, there are some common terms you can see here. If I take this omega here, this is omega common modulus of z square plus 1. This is equal to, if I take this term, this is z omega square plus 1, right? Modulus of omega square plus 1. We have this expression. Now you see here, this is omega by z is equal to modulus of omega square plus 1 divided by modulus of z square plus 1. Correct? Now see, this quantity on our right hand side, can we say this is always a purely real number? Why this is purely real number? Because modulus of any complex number are always real numbers or always real numbers. Correct? So this quantity is real number, this is real number, so division will also be a real number. So what observation you can see here, that if this is a real number, that means omega by z, this has to be real number, then only they can be equal. So what is the condition? That omega by z should be equal to omega bar by z bar. Why? Because if a complex number is purely real, this complex number is purely real. What is the condition? Z is equal to z conjugate. Agar complex number real hai, then what is the condition? Omega is equal to omega bar, z is equal to z bar. Correct? So if this is a real number, you can say this is equal to conjugate. So from this you have got some condition that omega z bar is same as z omega bar. We have got this condition from this. How can you use this to finally get the answer? If you see here, I can again take the same equation. थोड़ा आप इसमें ध्यान से देखो, इसको अरेंज कर रहे हैं हम. What is z mod z square? This is z bar omega minus what is mod omega square? I can say this is omega bar z. Correct? This is minus z plus omega is equal to 0. Just arranging the terms. And now you see, I have omega z bar is same as z omega bar. So what we can do here is, this is z. I can take this z common. This is z bar omega minus 1. And from these two, you can see, if I take omega common, this is omega bar z minus 1 equal to 0. I can write this. You can see. Now you can see here, z bar omega or omega bar z, both are equal. You can see, both are equal. So what I can say is, this is z minus omega, and I can take this common. This is z bar omega minus 1 equal to 0. I can take this common or this term common. Ultimately, both are equal. So from this, what does this imply? Either z equal to omega or z bar omega is equal to 1. Z bar omega is 1, or you can say omega z bar is equal to 1, because both are equal. So I hope this point is clear. How can you prove this? This is, sorry, I have written both the same thing. So basically this is, I should write this, omega z bar omega is equal to 1, or z omega bar is equal to 1. Basically what we have done is same, right? So this is how you can solve this. So important step for this question is this. Important step for this question, you can see how we have got this condition by rearranging the terms. So this one is this step in many questions you can apply. काफी questions में इस पे ये thought process हो सकता है question solve करने का. Okay. So now let's move to the next question. So next question is again, if iota z cube plus z square minus z plus iota, then show that modulus of z equal to 1. मतलब आपको complex number z का modulus find करना है. How can you find this? अब देखो, if you have to find this modulus z, तो one way to solve this is इसको आपको z is equal to x plus iota y, जो first thought आता है, उसको simplify करके you can solve for x and y and you can check उसका जो magnitude है that is 1 or not, right? That is one method, but that will be very lengthy method. See, can we directly factorize this? इसको आप directly factorize करने की कोशिश कर सकते हो. कैसे? You can observe something here. We have this is iota z cube plus z square. I can write this minus z as iota square z plus iota is equal to 0. I can write this. You can see what I have done is iota square is equal to -1. So I have replaced z -1 as iota square. Now what will happen if I take z square common? This will become iota z plus 1 plus iota z plus 1 equal to 0. What I have done is I have just taken this iota common and z square common. So from this you can clearly see this is z square plus iota into iota z plus 1 equal to 0. So you can see what are the roots, what are the conditions you have. Z square equal to minus iota or z is equal to -1 by iota. इसको arrange कर लो, you'll get this. Now from this you can see what is this z is equal to iota, because we know 1 by iota is minus iota. So you can write this. Now what is the z from this? Z you can see this is plus minus under root of minus iota. Correct? But see, the question is not what is complex number z. Even you can find this under root of iota also. आप इसको भी convert कर सकते हो x plus iota y की form में. Correct? You know how to write the square root of a complex number. So we can use that method also. But we are not interested in solving z. We are interested in what is the magnitude of z. So even without finding the roots, you can directly say, see, what is the modulus from the first case? From this case, this is modulus of z is equal to modulus of iota. What is modulus of iota? This is equal to 1. So एक बार तो देखो इससे तो prove हो ही गया. This is modulus of z is equal to 1. And if you just check this, you can clearly see from this, this is modulus of z square is equal to modulus of minus iota. And what is modulus of minus iota? This is equal to 1. And you can see here what is modulus of z square. This is same as modulus of z square equal to 1. So what does this imply? This implies modulus of z is equal to 1. So you can see from both the cases, from the second case and from this first case, you can have what is modulus of z. This is equal to 1. So now in mains exam, what you can have is what are the complex numbers which satisfy this. So I can write what are the complex numbers z is equal to plus minus iota under root of minus iota. You know, you can easily find under root of minus iota. If I want to find what is under root of minus iota, I'll just give you the method. Let's say this is x plus iota y. If I want to find, for example, under root of minus iota, isko assume kar lo, this is x plus iota y. So what is this? This is minus iota is equal to x square minus y square plus 2xy iota. This is 2xy iota. And from this you have two conditions, that is x square minus y square equal to 0 or 2xy is equal to -1. You can solve and get the values of x and y so that we will get the square root of minus iota. So question can be this, what are the roots of this? And this is the one question which we have solved, that what is the modulus of this complex number? This is equal to 1. So I hope this is clear. Now let's move to the next question. Now, if z is any complex number satisfying z minus 3 minus iota modulus less than equal to 2, then find the maximum value of 2z minus 6 plus 5 iota. Now in this question, I'll solve both. What is the maximum value and what is the minimum value? We will solve this part also. what is the minimum value of this expression. Okay, this question was asked in JEE Advanced 2011. Okay, now we will solve this question both mathematically and geometrically. Understand both the methods, both are important, because in some questions you can directly solve by using geometry, but sometimes it's not possible to apply geometry, so it's better to understand both the methods. Okay, first let's solve this mathematically. Method 1. तो देखो, I hope you know what is triangle inequality. तो मैं एक बार रिवाइज कर देता हूँ. What is Z1 plus minus Z2 modulus? This is always less than equal to modulus of Z1 plus modulus of Z2. And this is always greater than equal to modulus of Z1 minus modulus of Z2 का modulus. This is called triangle inequality. This is very helpful for maximizing or minimizing some modulus values. Okay. So see, we have to find what is the maximum minimum value of this modulus of 2z minus 6 plus 5 iota. Condition is given on this complex number, So what I can do is I can convert this complex number in the form of z minus 3 minus iota, 2 iota. Kaise? You can see this is 2z. This is 2z minus 3 minus 2 iota. And we have, this is 2z. You can see this is 2z minus 6 and this is 5. So I can say this is plus 9 iota or yes ka modulus. So this expression I have written in this form. This expression I can write here. Now from this you can see, I can say this complex number, the modulus of this complex number, this is some complex number z1. This is some complex number z2. So modulus of z1 plus z2 is less than equal to modulus of z1 plus modulus of z2. Right? This is plus modulus of 9 iota. And this is greater than equal to modulus of 2z minus 3 minus 2 iota minus 9 iota or iska modulus. You can see this is modulus of z1 minus modulus of z2, right? Now the maximum, now this expression, this is 2z minus 6 plus 5 iota modulus. This is less than equal to, this is constant, you can see 9 iota, modulus is 9, so this is 9 plus. Now if you have to find the maximum value of this expression, मतलब इसका maximum value लिखना पड़ेगा. What is the maximum possible value of this will be dependent on this only because this is constant. What is the maximum possible value of this? You can say this is 2 times modulus of z minus 3 minus 2 iota. What is the maximum possible value of modulus of z minus 3 minus 2 iota? So you can see this is less than equal to 2. If this is less than equal to 2, what is the maximum value? This is only 2. So what is this? This is equal to 13, right? Greater than equal to, this is, you can see 9 iota ka modulus is 9. So this is 9 minus 2 modulus of z minus 3 minus 2 iota modulus. Ye modulus of a minus b is same as b minus a, so I've just written like this. Now see, if you have to write the minimum value of this expression, minimum value कब होगा? जब ये quantity minimum होगा. Now what is the minimum possible value of this? So if you have to write the minimum value, you can see 9 में से you are subtracting something. 9 में से you are subtracting something. And if you are subtracting something from 9, it should be maximum. क्योंकि जितना 9 में से maximum value subtract करोगे उतना वो कम होगा. We want to minimize this. So इसको क्या put करोगे? You will put maximum value. So if I put maximum, what is the maximum possible value of this? अभी आपने देखा this is equal to 2. So this is, you can say 2z minus 6 plus 5 iota modulus is less than equal to 13, greater than equal to, this is 4, 9 minus 4, which is equal to 5. I hope this is clear how you got the maximum value and minimum value of this expression, all right, by using triangle inequality. Now we will see how we can solve this question geometrically. Okay, The geometrical interpretation is also important. So let's move to the next page. Yes. So देखो method 2. What is the condition given to you? Z minus 3 minus 2 iota modulus is less than equal to 2. Correct? ये देख लो. Z minus 3 minus 2 iota modulus is less than equal to 2. And you have to maximize, minimize 2Z minus 6 plus 5 iota modulus. Okay? You can check this. 2Z minus 6 plus 5 iota. We have to maximize and minimize this expression. Now first, let's understand the concept and then we'll solve this question. The concept part पहले समझ लो. See, concept क्या है? If you have Z minus Z naught modulus, this is equal to some value R. Then what is this locus? अगर Z naught fixed point है, Z is a moving point, then this represents a circle whose center is at the point Z naught and radius is equal to R. Correct? If you have any Z minus Z naught modulus equal to R, then this is the equation of a circle with center Z naught and radius equal to R. अगर ये less than R होगा, मान लो less than R, less than equal to R, that means it will be region inside this circle. अगर less than R है तो, और equal to R होगा तो circumference पे भी आ जाएगा. You can see, because इसका मतलब क्या हुआ? All the points which are at a distance less than radius from Z naught. ये center क्या है? Z naught. So this is one point which you have to remember. Second देखो, what is modulus of Z1 minus Z2? This is the distance. ये हमने last class में भी discuss किया था. Distance between complex number Z1 and complex number Z2, मतलब the points represented by Z1 and Z2. अब इस question पे आ जाओ. What does this represent? I can say this is region which is inside or on the circumference of the circle whose center is 3, 2 and radius is 2. यहाँ पे Z naught क्या हो जाएगा? This is Z minus Z naught modulus is equal to R. इससे कंपेयर कर रहे हैं. ठीक है? So you can see Z minus Z naught will be 3 plus 2 iota. What is 3 plus 2 iota? The point 3, 2. Radius is equal to 2. Correct? So if I just plot this, we are just plotting this region. This is center 3, 2, radius 2. So let's say this is the circle with center 3, 2 and radius 2. अगर radius 2 है, center 3, 2 है, तो definitely it will touch x-axis. You can see this is the x-axis. X-axis, that is real axis. We are talking about the complex number because इसका radius क्या है? 2. This is 90 degree, right? So Z जो है, Z is satisfying this. That means all these complex numbers, these are Z. ये सब Z है और on the circumference क्योंकि equal to भी है. We have both the cases equal to and less than, right? So this is the region in which Z will lie. इनमें से कोई भी complex number Z हो सकता है because this is the condition. Now see, we have to find the maximum minimum value. I can write this is equal to 2 times modulus of Z minus 3 plus 5 by 2 iota. I can write this. So what is this? Can we say this is 2 times the distance between the point Z and 3 minus 5 by 2, 3 minus 5 by 2. You can see ये क्या है? देखो Z, I can write this is 2 times modulus of Z minus 3 minus 5 by 2 iota. I hope this is clear. So this is Z minus 3 minus 5 by 2 iota. That means this is the distance between the complex number Z and 3 minus 5 by 2. Up 3 minus 5 by 2 will be a point. You can see this is 3 2. तो इसी का डायमेट्रिकली अपोजिट, मतलब इसी के बिल्कुल परपेंडिकुलर लाइन पे यहाँ पे 3 minus 5 by 2 लाई करेगा. करेक्ट? इसका x कोऑर्डिनेट सेम ही है, 3 minus 5 by 2. Right? So now see, these are the complex numbers set. In सब complex numbers में से which complex number is at the maximum distance? Because हम distance between Z and 3 comma minus 5 by 2. So you can see here this point will be at a maximum distance from the point 3 comma minus 5 by 2. So what is the maximum possible distance? Because इसका आपको maximum value find करना है. What is the maximum possible distance? You can see this is 2, this is 2, 4, and this is 5 by 2. So what is this? This is maximum value. इसका जो maximum value होगा, that is maximum distance. Maximum distance कितना होगा? This is 4 plus 5 by 2. 2 times 4 plus 5 by 2. You can check. This is equal to 13. So this is the maximum distance, maximum value of this expression. Now, what is the minimum possible value of this? You can see here. In sub-complex numbers, में से which complex number will be at the minimum distance from this point 3 comma minus 5 by 2? This point will be at the minimum distance. और उसका minimum distance क्या होगा? 5 by 2. This distance. This is the minimum distance. So this is 2 times 5 by 2. ये 2 is because of this. यहाँ पे बाहर 2 था इसलिए. That's it. So what is the minimum possible value? This is equal to 5. So I hope this is clear how we got this geometrically, how we got this pure by using pure equations. Okay. So this type of questions are very important. ऐसे geometrically हमने approach किया. We'll solve some more questions geometrically. आगे भी आपको मिलेंगे. ठीक है. Now let's move to the next question. Oh, nice. Now this is one very interesting question which was asked in JEE Advanced 2010. So देखो यहाँ से. The question here is Z1, Z2 are two distinct complex numbers and given Z is equal to 1 minus TZ1 plus TZ2. ठीक है? इधर आ रहा. For some real number T is some real number which is between 0 and 1. If argument of omega denote principal argument, मतलब हम यहाँ पे principal argument की बात कर रहे हैं for किसी भी complex number omega के लिए, मतलब this is representing the principal argument. ठीक है? Then which of the following options are correct options? So now see. Again, we have to talk about argument. We have to talk about argument. We have to talk about modulus, and you have to talk about conjugates also. यहाँ पे सब कुछ involved. This is very important questions involving all the concepts of complex number. See, geometrically थोड़ा सोचो इसके बारे में. If you have Z is equal to 1 minus T Z1 plus T Z2, correct? And T is a real number which is between 0 and 1. 0 and 1. T is between 0 and 1. इसको देख के आप क्या कमेंट कर सकते हैं? What is the geometrical interpretation of this? Think about this. Can we say if I just divide by 1 minus T plus T? What I have done is I have just divided by 1. 1 ko I have written 1 minus T plus T. So this you can see, this is a positive number. This is a positive number because T is between 0 and 1. This is positive. T is positive. T is positive. By looking at this, are you getting something? This is, you can see, a formula which you are forming. You can see it is a form of mz1 plus nz2 upon m plus n, where m and n are positive. 1 minus t are positive. Correct? So what is this formula? This is a section formula for internal division. If a complex number z is represented as this, matlab z is dividing z1 and z2 in some ratio m:1. So what is the geometrical significance of this? You can see that if I say this is z1 and this is z2, then z will be a definitely point between z1 and z2. It cannot be outside z1 and z2. Collinear hoga, and z will be between z1 and z2. That means z will divide z1 and z2 internally. अब अगर ये clear है, then you can easily solve the question geometrically. अब तो सीधा सीधा आपको equations बनाना है. You can see. What is option A? Check option A. Z minus Z1 modulus. What is Z minus Z1 modulus? Distance between this. This is Z minus Z1 modulus. You can see this is, let's say, point A. This is, let's say, point B, and this is point B. So what is this first option A? This is PA plus what is Z minus Z2 modulus? Z minus Z2 modulus is PB. This is PB. And this is, you can say, Z1 minus Z2 modulus kya hoga? This is Z minus Z2. This is Z1 minus Z2. This is AB. Now, is this statement correct? अगर P between Z1 and Z2 है, P is between A and B, then definitely PA plus PB is equal to AB. So I hope this is clear. First option is correct. मतलब option A is one answer. Now let's talk about option B and option D. Argument of Z minus Z1 is equal to argument of Z minus Z2. Now understand this. What is Z minus Z1? इसको आप रिलेट कर सकते हो वेक्टर से. This is, let's say this is Z minus this is Z1. So this is Z1 minus Z, right? जैसे आप वेक्टर में क्या लिखते हो? This is, let's say if you have this vector which is starting from point A, this is point B. So this is AB vector. What is AB vector? Final minus initial, position vector of B minus position vector of A. तो ये अगर आपके पास ये जो पॉइंट है, दिस इज कॉम्प्लेक्स नंबर Z1, दिस इज कॉम्प्लेक्स नंबर Z2, तो व्हाट इज दिस? B माइनस A, दिस इज Z2 माइनस Z1. ये सब पता होना चाहिए वेक्टर से, हाउ टू रिलेट कॉम्प्लेक्स नंबर्स. ठीक है, एक बार ये देख लो. AB वेक्टर, दिस इज फाइनल वेक्टर माइनस इनिशियल वेक्टर, फाइनल वेक्टर Z2 माइनस Z1. ठीक है, नाउ सी हम कहाँ थे? यहाँ पर है. What is Z minus Z1? Z minus Z1 is a vector. This is final point, this is initial point. Z1 से start होगा और ये Z पे जाएगा. This is Z1 minus Z. ये देख लो, Z minus Z1 vector. Z minus Z2 vector क्या होगा? ये आप ऐसा बोल सकते हो, final minus initial. तो यहाँ से you can see Z minus Z2. ये बराबर है. You can see final minus initial, final minus initial. This is the vector, you can see. हाँ, ठीक है. And तो यहाँ पे देखो इन दोनों का आर्ग्यूमेंट. Wait, मैंने कुछ Z minus Z1, this is Z minus Z1, ठीक है. This is Z minus Z2, this is एक second. This is, wait, let me draw this correctly. This is Z2, ये जो पॉइंट था, this is Z2, this is B. ठीक है, तो ये this will be the vector something like this and this is the vector something like this. एक बार ये चेक करना. This is final minus initial, this is final minus initial, ऐसा. ठीक है, तो now see क्या दोनों का आर्ग्यूमेंट सेम है? You can see these two vectors are collinear, एक लाइन में है. You can see these are collinear, but दोनों का डायरेक्शन is not same. मतलब the argument of both vectors are not same. उनके बीच में एंगल हमेशा किसका बनेगा? पाई का बनेगा. If these two are two vectors, ऐसे vectors हैं, इनके बीच में what is the angle? This is pi. If both the arguments are same, तो the angle between them should be 0, right? Now, but if you talk about the second part, मतलब that is option B is wrong. Option B is wrong. But if you talk about this option D, you can see Z minus Z1. You can see this is final minus initial. So you can see this is Z minus Z1. And this is Z2 minus Z1. You can see this is Z2 minus Z1 vector. I'll just remove this. Now you can see this is Z2 minus Z1. You can see this is Z minus Z1 and this is Z2 minus Z1. दोनों Z1 से स्टार्ट हो रहे हैं एंड एक Z पे जा रहा है, एक Z2 पे जा रहा है. So now see, क्या दोनों वेक्टर्स का डायरेक्शन सेम है? So what is the angle between these two? Angle between these two is 0. So argument of this vector and argument of this vector will be same. You can see, अगर आप argand plane पे जाओगे, let's say this is one vector, this is another vector. So what is the argument? दोनों का argument देखो same ही आएगा, right? So this is how we can say option D is correct option, but option B is not correct. I hope this is clear. Now let's move to the option C part. Now how will you involve conjugate of the complex number? You can see यहाँ पे we have a 2x2 matrix जिसपे आपको conjugate को involve करना है. How can you involve conjugate? You see here, if you, let me write it here. Sorry, इधर ही कर देते हैं अपन इसको. If you just take the same expression, some same expression, यहाँ से आप देख लो. I can arrange this. You can say this is Z is equal to, you can see that is equal to Z1 plus Z2 minus Z1 into T. इसको अरेंज कर दिया हमने, you can see. So from this, if you arrange the terms, what is T? This is Z minus Z1 divided by Z2 minus Z1. And you can see T is a real number. It is given in the question. If T is a real number, that means this is a real number. If this is a real number, what is the condition for a complex number to be real? Z should be equal to Z conjugate. मतलब अगर ये real है तो this is Z minus Z1 divided by Z2 minus Z1 should be equal to Z conjugate minus Z1 conjugate divided by Z2 conjugate minus Z1 conjugate. क्या कर दिया हमने? दोनों के conjugate को बराबर कर दिया. So now if you arrange this, you can see this is Z minus Z1, Z2 conjugate minus Z1 conjugate. Cross multiply minus this. So that means option C is also the correct answer. Okay. So I hope this question is clear. How we have solved this question by using pure geometry. सिर्फ हमने geometry यहाँ पे use किया है, ठीक है? तो ऐसे आप geometry को use करके you can easily solve the questions. Especially जहाँ पे we have to find angles, modulus. थोड़ा सा आप इस पे geometry apply करना सीखो. That will be good for you. Okay. Now let's move to the next question. एक काम करते हैं. Next question I'll take in the next video. अदरवाइज ये बहुत लेंथी हो जाएगा. तब तक आप इन क्वेश्चंस को एक बार ट्राई करके देखो. नेक्स्ट वीडियो में अगेन आई विल टेक द नेक्स्ट क्वेश्चंस ऑफ द कॉम्प्लेक्स नंबर्स. ठीक है. सो थैंक यू फॉर दिस for watching this video, and please do subscribe this channel so that whenever I upload a new video you'll get the notification. और notification बटन को भी आप ऑन कर लीजिए. Okay, so that's it for now. Thank you.